Good morning everyone. I am Dr. Shefina. Today we are discussing about CMIA or chemiluminescent microparticle immunoassay. The term chemiluminescence refers to a chemical reaction emitting energy in the form of light. So this technology can be used to determine the presence of antigen, antibodies, drugs or enzymes in samples. In our lab, we are using this technology for screening of transfusion transmitted infections, that is of HIV, hepatitis B and hepatitis C virus. For hepatitis B at our institute, we are testing HBsAg antigen and anti-HBc antibody. And also in the machine, we have option for testing syphilis. So for according to our institute's requirements, we can customize the transfusion transmitted infection testings. Coming to the principle behind chemiluminescence. So it is the emission of light when an electron returns from an excited or higher energy level to a lower energy level. So in this technology, there are these magnetic beads or microparticle which are coated with capture antigen or antibody. This will bind to the sample analyte or the antigen. Then the actinium labeled detection conjugate will bind to these complexes and they will produce the measurable light. And this is the machine we are using. So this is the About Architect I system, which is a fully automated CMIA analyzer. So this machine will perform the sample preparation, test performance, photometric measurement, and even the data evaluation. Advantages of this fully automated system: it has high sensitivity and specificity with wide analytic range. Minimum sample volume required is 150 microliter. It has shown minimal interference and reduced exposure to radioactivity. There is good stability of reagent and fast turnaround time, that is around 20 minutes, and excellent reproducibility. Another benefit of this fully automated machine is we can load up to 65 samples simultaneously, but with full random access or capability for individual sample loading also. Also, any machine error can be detected remotely by the company personnel from their location itself. Coming to the disadvantages: high initial cost, cross reactivity, and the installment is dependent on the infrastructure of the institution, and also there is a learning curve. The recommended quality control of analyzer is each control, that is the positive and negative control that is provided by the manufacturer. It should be tested once in every 24 hours, and the result or the control values must be within the range that is specified in each control package insert. So for example, for HIV, these are the positive and negative controls provided. We have to load the control in aliquot tubes. After loading, place them in the sample carrier, that is a barcode labeled sample carrier. Now we can place or load the carrier as same as how we are loading it in the loading it for the donor samples, and the barcode reader will read the QC and the test will be performed, and this is the result after the QC. So here we can see the positive and negative controls and the result. Another feature of this CMA analyzer is it will store the QC data and it automatically provide LJ charting. So here we can see the LJ charting of HIV. So the first one is the negative control and second and third are the positive control LJ charting. Coming to the reagents of CMIA. For every test, there will be a reagent combination, that is of microparticle reagent, conjugate and assay diluent. Here we can see the combination of the hepatitis C virus, and this is the reagent carrier. So this is color coded. So the reagent should be placed matching with the colors. These are the reagent kits for HIV, HBsAg, anti-HBc and for hepatitis C. Once these reagents are loaded in system, it has a stability for 30 days. For reagent loading, place the reagent bottles on matching color section of the reagent carrier and load them to the machine. Now the carrier transporter will takes up the carrier and moves it past to the barcode reader. Barcode reader will identify the reagent kit, and we can see on system the number of reagent size will increase. Coming to the testing. So here we have taken barcode labeled donor samples. First step is centrifugation. So place the donor samples, balance it, and centrifuge the machine according to your standard operating procedure. These are the same samples after centrifugation. This is barcode labeled sample carrier. Now the centrifuged samples should be loaded into this carrier, and it should be pushed completely into the carrier, and the barcode of the tube should be facing out. Now we have to scan first the barcode of carrier. So the data will appear on the screen. We can see that. After that, we have to scan the barcode of sample tube. Now the donor detail will appear. Here we have to select the test to be done. So here we have selected hepatitis B, hepatitis C, and HIV. Now place the sample carrier into the empty rack of machine, and we can see the indicator is illuminating. Now the carrier transport will takes up the sample carrier and moves it to the barcode reader. So now the system will automatically show the test, that is the donor details and the test to be done. Here we have to ensure that the number of sample loaded should be matching with the number of sample and the test that is appearing in the system. So this is the result screen after testing. So here we can see the result along with whether the test is reactive or non-reactive will also appear. And this data can be connected to the Institute Laboratory Information System. The sample to cutoff ratio is 1. So any report less than 1 is non-reactive, as we can see here. And if any report, if it is more than 1, it is reactive. And the all donor details or the data reports we are documenting for 5 years, and if any report is reactive, we'll recall the donors according to the national policies. This is another report. Here we can see for the same donor the HBsAg is reactive, and also here we can see the core antibody is reactive.
So thank you for that and taking us through the entire procedure. So I'd like to ask a few questions for clarification of the audience. So we have been doing ELISA method for testing these infections since a very long time, and of late the CMIA has been in place since quite a while. So can you please compare and contrast between the ELISA and CMIA methods for testing for these TTIs?
Yes, the comparison between CMIA and ELISA. The principle behind CMIA is chemiluminescence, whereas the ELISA it is colorimetry, that is the enzymatic reaction associated with the immune complexes. Then comparing with ELISA, the CMIA have a higher sensitivity and also it gives the result faster than ELISA. And CMIA it is fully automated with random access, whereas ELISA it can be semi-automated or it will be a completely manual method. Then comparing with ELISA, the CMIA is less prone for interferences.
So, what is the sensitivity and the specificity of CMIA for the TTIs which you have shown, like the HIV, Hep B, and Hep C?
So for all the three infections in this system, the sensitivity is 100% and specificity is more than 99%.
Right. Okay. So, as you showed that you're also testing for the core antibodies. So these are not mandated in our country, although that's an additional test to improve the layer of safety. So, what kind of antibodies do you test, whether it is IgM, IgG, or it's a combination of IgM and IgG?
Yes, ma'am. So, core antibody testing is not mandatory in India for blood donation screening. So, the Abbott Architect I system that I showed detects both IgM and IgG antibodies, that is, total antibodies to the hepatitis B core antigen. So, this is detecting past, current, and resolving hepatitis B infection.
So can you compare and tell me what is the window period of these infections when you test with serology versus the window period of these infections when you use an ID NAT, which is not yet mandated in our country, but as I think it considerably reduces the window period by a lot many days. So if you can just compare and contrast both, so that will give a better insight to the audience.
Yes, ma'am. So the NAT considerably shortened the window period comparing with that of the serology. When comparing the window period for HIV in NAT it is 4.7 days, whereas in serology it is 15 days. Then for Hep C, NAT it is 2.2, and for serology it is 58.3 days. Then Hep B, NAT it is 14.9 days, whereas for the serology it is 38.3 days.
Well, thank you, Dr. Shafina, for answering all our questions and informing us in detail about the entire process. If anyone has any queries, please drop your questions in the comment sections below and we can get back to you. Thank you.